In order to calculate the dot product of vector 2u and vector 3v, we first have to calculate each of those vectors individually based off the vectors that were given in the problem. So to calculate vector 2u, we're going to take the vector u and multiply it by the constant 2. And the way that we do that in terms of coordinates is to distribute that 2 through and multiply the constant by each of the coordinates. So we'll have 2 times 3 and 2 times negative 2. That will result in vector 2u being equal to 6, negative 4. And now this vector will have its own set of x and y coordinates, which we're going to use when we do the dot product. To calculate 3v, we're going to do a very similar procedure. We again have a vector being multiplied by a constant, so we take that constant and we multiply it by each of the coordinates in the vector. So we'll have 3 times 1 and 3 times 3, which will give us vector 3v being equal to 3, 9. And this too will have a new set of x and y coordinates, which we now can use to calculate the dot product. So to calculate the dot product between 2u and 3v, we're going to multiply or find the product of the x coordinates of each of the vectors and add that to the product of the y coordinates of each of the vectors. So we'll have 6 times 3 plus negative 4 times 9. This is going to give us 18 plus a negative 36, which we can simplify to our final answer, which is that the dot product of 2u and 3v is equal to negative 18.